Hello everyone, I am here to explain about our COA assignment and our topic is comparison and conditional operations in 8051. And I am here to begin our presentation with the introduction part. In today's sessions, we will discuss one of the most important topics in computer organizations and architecture, that is the comparison and conditional operations in the 8051 microcontroller. Before moving to the concept, let me briefly explain why topic is so important. Microcontrollers are the brain of the most embedded system that we seen around us. Whatever it is, automatic machines, traffic signals controller, or a temperature monitoring system. In all these systems, the microcontroller consistently makes decisions by comparing the data and executing instructions based on the conditions. So comparison and conditional operators act like the decision-making power of the 8051. Without these operations, the microcontroller would not be able to decide between two values to take actions according to changing situations. For example, imagine a temperature sensor. If the temperature crosses a certain limit, the fan should be automatically turned on. Such smart response are possible only because of compression and conditional instructions inside the 8051. That's why this topic is just theoretical but also highly practical in real life applications. Concept meaning. Now moving on the concept meaning, the term comparison means checking the relationships between two values for intense checking. If one value is greater than, less than or equal to another in the 8051 microcontroller, comparison is often done using instructions that affect specific flags in the status registers. These flags indicates the result of the comparison which can then be used for further discussion making. The second part is conditional execution. It means that the particle instructions or block of code will run only when a specific condition is true. For example, the program may jump to another location to perform a task only if two numbers are equal. This helps in microcontroller for the low program and avoids unnecessary execution of codes. Together, these two concepts, comparison and conditional execution, make the 8051 capable of intelligent and efficient processing. They give the microcontroller the ability to think logically and respond dynamically to input data. In simple terms of transfer the microcontroller from just a calculator into a decision maker. So overall, these operations are the foundation for automation, robotics, and all real life embedded applications that they rely on logical decision making. Thank you. And the next part will be explained by my teammate Adil.
To explain largest and smallest number, which focuses on how we find the largest and smallest number using comparison and conditional operations in 8051 microcontroller. In simple terms, comparison and conditional operations allow the microcontroller to make decisions automatically. These are essential parts of automation and control systems because they let them check values and decide what actions to take next. For example, we can use items to determine whether one value is greater, smaller, or equal to another, and then store or act accordingly. Let's start with the concept of finding largest number. Suppose we have two numbers stored in memory location 50H and 51H. The microcontroller compares these two values. If a number in 50H is greater than the number in 51H, it shows the larger one in another memory location, which is 52H. In simple words, the program compares two numbers and keeps the larger one safely for later use. This operation is quite common in systems like games where you need to compare player score and record the highest scores. Next, we have defined the smallest number. This is quite similar to the previous operation, but we have the opposite logic. Let's say we have temperature reading stored at 53H and 54H. The microcontroller compares these two values and store the smaller one in location 55H. This kind of operation can be very useful in systems where we need to find minimum readings, like in temperature control system or monitoring low sensor values. Both of these operations rely on comparison instruction in the 8051 microcontroller. These instructions check whether one value is greater, smaller, or equal to another. Then they then set specific flags in the processor. Based on those flags, the next instruction decides what to do. For example, way to jump to another line of code or continue normally. In real world application, these applications are very powerful. They are used in gaming systems to compare player scores and decide who wins. They are also used in temperature based systems to decide whether to turn a fan on or a heater on or off. And in industrial automation, they help control machines, counters, and timers by comparing different values continuously. To conclude, the process of finding the largest and smallest number using comparison and conditional operations is a fundamental concept in microcontroller. It helps machine make intelligent decisions automatically without human involvement. These operations improve system accuracy, reliability, and automation, which are the main goals of modern embedded system. And the next topic will be and the next topic will be done by
Hello everyone, myself Nafis. I would like to explain the positive or negative increment and decrement. Now let's move on, which focuses on checking whether a number is positive or negative, and on performing increment and decrement operations using the microcontroller. In real-time systems, it's important for a microcontroller to recognize the sign of a number because the behavior of a program often depends on whether a value represents gain or loss, rise or fall, or any similar condition. In the 1851, numbers are stored in binary form, and when a number is signed, its most significant bit, also called the MSB, is used to indicate the sign. If the MSB is 0, the number is positive. If it is 1, the number is negative. So the microcontroller can check the sign bit to decide what type of number it is dealing with. Next is, for example, imagine that a signed value is stored at memory location 56H. The program checks the MSB of this value. If the number is positive, it stores 00H in location 57H to represent positive. If the number is negative, it stores 01H in 57H to represent negative. This simple operation helps the system keep track of the nature of the data being processed. For instance, in an electronic weighting machine, the same logic can help determine whether the measured force up or downward. Let's say a counter value is stored at 58H. The program starts by incrementing this value repeatedly until it reaches 0AH. After that, it starts incrementing back down to 00H. Once it hits 00H, the cycle repeats again and again. This process is used to simulate counting operations, blinking patterns in LEDs, or timing intervals in embedded systems. Next is the 8051 provides simple instructions like INC for increment and DEC for decrement. They are executed quickly and do not affect the carry flag, which means they are perfect for short repetitive arithmetic operations. They help build loops, control iterations, and handle repeating tasks without using complex logic. Thank you. And the next slide will be continued by my teammate Muhammad Mustafa.
Myself Muhammad Mustafa. I am Muhammad Mustafa. In real life application, these two operation have wide uses. In digital clock, The microcontroller use increment and decrement operation to control seconds, minutes, and hours. In industrial counters, counters, this interaction help track and number of items on a conveyor belt, and in temperature or speed monitoring system. The microcontroller increase and decrease control signals gu- gradually, gradually monitoring balance in a system output. To conclude, it show how the 1851 uses simple yet powerful concept, sign checking, increment and decrement to make intelligent decision and control repre- rep- repetitive actions. These basic operations from the backbone of many automatic system, making a micro microcontroller flexible, actuator, and efficient in real world task. Thank you.